Despite knowing the broad sequence of events that led to the formation of the Milky Way galaxy, the Sun, the Earth, life, and us, there are still gaps in the cosmological understanding of our creation. Indeed, it is during this time, up to and beyond the first million years of cosmological history, that scientists believe dark matter steps up to shape the future of the universe. The existence of dark matter was first considered in 1933, when Swiss astronomer Fritz Zwicky was studying the Coma cluster of galaxies, some 320 million light-years away from the Earth. These galaxies seem to be moving too fast for the cluster to remain a cluster. Estimates of the masses of each galaxy in the cluster, based on the luminous stars that could be seen and counted, gave a number that was some 10 times less than what would have been needed to keep the group together, given how fast the galaxies were moving. To explain this apparent discrepancy between the two methods of determining mass, Zwicky proposed that there must actually be a lot of unseen mass lurking out there amongst the stars, gas, and visible matter. He called it Dunkle Materie, German for dark matter. In the late 1970s, pioneering astronomer Vera Rubin was studying the rotation of the Andromeda Galaxy, the closest spiral galaxy to our own, when she noticed that something didn't add up in the motions of its stars. At the time, she and her colleagues studied cryptic punch card readouts from their instruments, but to this seasoned astronomer, the problem was as clear as day. Galaxies were expected to spin fast close into the center, while stars at the edges would make a more stately progression. But the punch cards were telling a different story. The stars at Andromeda's outer edge seemed to be moving just as fast as those in the central bulge, with the tips of its spiral arms whipping around with implausible speed. The only explanation for such a movement without violating the universe's fundamental laws of motion was that the stars themselves were only a part of the overall mass of the galaxy. Rubin calculated that the visible matter must represent just 15% of what was really there, and that the Andromeda Galaxy must be cocooned in a much larger halo of invisible, dark matter.